My name's Steve Poole. I'll introduce myself slightly better. Before I talk about anything, can you talk to you about the usual IBM boilerplate, which you've probably seen elsewhere, which is in loud shouted capitals that says anything we tell you is for informational purposes only, and I'm not quite sure what other purposes it could be. So this is me, Steve Poole, work for IBM. I've worked in the Java space for a very long time. Started pretty much before Java was one, when it first started and came into the VM, into Hursley. Currently working on OpenJDK because that's cool and sexy, and one of the things I'm doing is things like the PowerPC I export with SAP. We're trying to get that into OpenJDK. So active in IBM's been very active in Java for a very long time, and we continue to be active. And what I'm going to talk about today is some experimental technology that we're trying out, trying to understand how we deal with some of the new pressures and existing pressures that are coming to us from our customers. So if at any point I pause and it looks like I'm reading the deck, it's because I am, because this isn't my deck. And I think I'm up to speed with it, but if I pause, you know it's because I've lost my way, so just bear with me. So before I start, this is experimental technology. So we're delivering it in our Java 8 beta. You can go download it if you want to try it. The easiest way to find it is to Google for IBM Java 8 beta, and that'll take you to the link. It's an open beta. You can sign up for it. You can download it. You can use it. So hopefully, when I finish this discussion, what you'll be able to understand about is why we've decided that we needed to look at multi-tenancy support in the VM, understand some of the challenges that we see being dealt with and some of those we think we've dealt with, and perhaps put this in a wider context and understand why there is a pressure across the board to improve what's called multi-tenancy support across the whole software stack. It's not just a VM piece. We're playing our role in the whole of software's transition to shall we say, a more services-based situation. Okay, so basically I'm going to tell you about what multi-tenancy is, and I said I'm going to put it in context with everything else that's going on, the different parts of the software stack. Then we'll have a look at specifically what we have to do for the VM, the challenges that a VM faces, and we'll wrap up. I'll give you a sort of pseudo demo of the technology that we've got, and I'll also talk about some of the performance characteristics and the benefits that we're seeing, and then we'll wrap up, and anybody who wants to ask me questions can feel free to do so. So let's start with what is multi-tenancy. Now, I find I have this conversation with people, and a lot of people don't actually understand what multi-tenancy is. So before I go into the details, I'll try and give you the snapshot view. So how many people here have used Jira or something like that? You must have a few. Okay, so if you've used a Jira system and you've got n number of projects, then that's not multi-tenancy. Right? A project is not a tenant. If you had n number of Jira instances and every single one of those looked like it was completely separate, so you could have one project in each Jira instance, but under the covers it was still one instance of Jira, that's multi-tenancy. Multi-tenancy is about removing some of the overhead and duplication, but making it look to you as the end user as if you've got a whole system. So that's where it fits, and you'll see that across the board, and you'll see why we're trying to do that and why everybody thinks it's a good idea to try and find ways of sharing more stuff. So here's another way of looking at this. Everybody probably has one of these, or you've bought one of these, or you know somebody's got one of these. This is one of these very complicated Harmony TV remote control systems. It's something you can program to, if you've got 5 different devices and they all do different things, you can go buy one of these. Really expensive, nice and complicated. And for geeks, that's great. My wife, I've got one, my wife hates it because it's far too complicated, never works for her. Okay. I also bet that a lot of you have got one of these. Okay, so a little Apple remote control. Less buttons, less simpler, more simple, less moving parts. So when you compare these two, right, you can argue at one level that actually the Apple version is the one that you should go with. Because from their point of view, it's cheaper to produce, it's got less moving parts, it's simpler. Complexity is a killer for us. And multi-tenancy is about trying to identify complexity that you don't need. Duplication of complexity, it's the sort of thing you're trying to get rid of. So we're trying to find a balance between the sophisticated but the expensive and the simple and cheaper. There is a balance, and it won't be the same balance for everybody. So there will be, as you will see in the diagrams that I start to go through, there are stages of this. But start to think about this as saying to yourselves, why do I need that extra level of complexity? Do I get the value from it, and how would I get rid of it? Oh, excuse me. Okay, so it's not really a hardware story. Well, it is a hardware story, but actually we all know how to share hardware. It's more about software stack. So it's about simplicity. So how do you get rid of all those extra pieces that you don't need? You may not realize that you need to do this, but you'll begin to see when you start thinking about where software is going, that every application that you own, right, whether you've bought it, whether you've written it, when you start to move into the new worlds, the software as a service type worlds, you need to start thinking very much about how you deal with having more complexity than you need. How do you get rid of it? The reason is that if you can make it simpler, it's cheaper. So it's cheaper just the fact it's from a maintenance point of view, but it's also cheaper from a diagnostic point of view. It's the funny thing is you have two instances of the same application, completely configured the same, and you still end up with issues. So if you had the opportunity not to have two instances, but you could have just one, then it would be valuable in all sorts of ways, not just in the space, let's say, but also in the terms of how much it costs you to look after. So, and again, having less, one of this rather than two of this, means from a general performance point of view, from a general predictability point of view, you understand what's going on. You've got less to worry about, okay? What we really don't want to end up, and this is what we have a lot of, is you have people who have the same setup and they configure it and copy it and have it running on thousands of different setup machines. Right? And you have to ask yourself that why they're doing that. On many occasions, having 10,000 machines all running the same set of software, is that the best way forward? Well, at one level, you're having to deal with 10,000 real things. And it would be very good if you could find a way of centralizing the bits that you need to centralize, that you can get away with centralizing, that you realize actually you don't need to have n number of copies around. You want to just have one. So this isn't a choice really between having one stack, one piece of hardware, one ThinkPad, one desktop, one laptop, or lots of shared stuff, right? There's a range, and you can choose where you want to jump in, and it's a risk-value assessment. So this wouldn't be an IBM pitch without some sort of roadmap or architecture diagram. This isn't quite an IBM one, but it's close. So on the left-hand side, S0 singleton, that's the standard stack. So those of you who don't think you're using multi-tenancy, you're already on the diagram, because the first thing is the stack that says there's no multi-tenancy. And after you think about it, actually that's the ideal image that we want to present to everybody. So the challenge from a multi-tenancy point of view is how I take that column on the left, the first ones, S0, and make it appear to be the same on all the others. How do I present that in such a way that the guy at the top, the little tenant at the box, gets to see what's underneath it in the way that he thinks he should see it, which is this full stack. But actually, you as a provider or an application provider is actually not doing that, and you're sharing pieces to improve your bottom line, to improve your cost performance, to improve the reliability of your systems, and so on down the stack. So let's just walk through this stuff so you can see. So I said the first one, S0, that's what you have today. That's your system. Okay? Nothing special there. Then you move up the stack and you talk about sharing the hardware. So now I've got two sets of 2 OS stacks. Whether you've Alpar'd it or there's a virtual machine, there's all sorts of ways of sharing it, but effectively you're sharing at the lowest level. You know, there's a hypervisor, your Alpar. It's really easy. It's what a lot of people do because it's easy to get your head around. Resource management is straightforward. I can divide, if I have a machine with 4 processors, I can say those 2 processors to the left and those 2 processors to the right. Easy to do, a lot of people do that. The next one up is actually sharing the OS. And this might be running applications in a set of virtual boxes or equivalent. You could argue that it may just be running multiple app servers on the same machine, but the intent is, in this sort of configuration, you've got one OS. The interesting thing is that by sharing one OS, you can free up significant amount of memory, right? The reasons that these things are in their stack is because each of them provides benefit. And mostly the benefit is improved, what's called density. You can get more into the system because you can share more. And if you can get more into the system, then if you are providing this as if you're hosting this, or if you're providing this as a service, then you can get more for your more bang for your buck. Okay? And it goes on. So you can get to multi-apps. Now in this one, as you can tell, now we're saying, let's share the middleware layers. Let's share the database. So the schema box on this is, it's best to think of it as like, it's just tables. So separate tables, one database instance, one set of middleware instances, one set of OSs. Okay? So again, you can see there's benefit, but there's risk. And the risk is isolation, resource management, stuff like that. But these are the options. There's a multi-tenant one, and this is where you're sharing one application. This is a stack where at the top you've got one application. So this is where we play. This is where the VM comes into position. This is the JVM sharing one application being shared and provided to users as if they were multiple applications. And there's actually one even higher than this, which is the sort of nirvana at the moment, where you have one application that's providing in a multi-tenancy mode, and even the database, the tables are being shared. There are clever things where the idea is you're just sharing so many rows in a table. Right? This is where people want to go. So this is a spectrum from you sharing absolutely nothing all the way through to, hey, do you want to share everything? So we're going to play the VM multi-tenancy is in this last 2, and I'm going to talk about what we've done, how we're doing it, and some of the benefits we're getting from it. The thing to remember is that all the way through, people are putting pressure on the providers of the pieces of this stack to do this. It's the sharing, because it reduces complexity, sure, but it saves resource, it increases density. Increasing density means I can provide a service to you less than my competitor because I don't need to have a bunch of S0s. I can have less hardware and use more software to provide the service. So therefore, it's cheaper, it's more competitive. And that's the driver. Software as a service is very interesting as an architectural statement and about building applications, but that's driving these sorts of pressures. So you're going to see this more and more and more. This is not IBM saying, we think this is the way it's going to be. This is already happening, and you'll be seeing more and more of it. So it's a thing to start thinking about when you're building new applications about what's coming around the corner. Keep an eye on this as technologies appear that will help make this happen. So the trouble is, a lot of this requires engineering effort. You've got to do things, okay? And in the VM experimental things that we've been doing, what we've tried to come up with something that actually requires that you don't actually make any application changes. So, just to end up, the importance of this diagram is that it talks about sharing, but in fact, from the tenant point of view, whoever's at the top, actually what they think they're getting is a complete stack. And that's what we're trying to make happen. So why we do this? Well, I've been talking about it, but if you think about it, as I said, if you can provide this service if you can do it in a much cheaper way than your competitors, then the value to you is obvious. You know, I can undercut my competitors. Why would I not want to do that? If I can get that sharing, if I can reduce the costs, and I can get it out quicker, okay, then that's great. From an end user's point of view, the reason that you want to jump into this stack is you don't have to maintain all the hardware stacks. You have the opportunity to get the capabilities, the separation of your application. So if you control up to your favorite provider and say, I want a new instance of a machine, please, to run this application, and he says, yeah, that'll be $1 a year, and we'll have it instantly for you, then you'll buy into that, right? Now, you have to decide whether you value, what you value in that argument, and whether or not you care about how it's provided, right? But if you've got an SLA, and you trust these guys, and they turn up and say, yeah, I've got what you wanted, then whether or not it's one machine or 10 machines, it doesn't matter to you. The fact is you get what you want that you can make use of as soon as possible, right? From a provider's point of view, it's just, as I say, it's a no-brainer. The more we can do this, the more I can be competitive, the more money I can make. And from other things, from an agility point of view, it's really easy to spin these things up and provide new versions. It's the same thing. The more hardware you have, the harder it is to maintain. Somebody has to look after it. So even the providers of machines, even if they weren't totally up to needing to do this, can see the value in taking one machine, splitting it in two. So not only from a point of view of being able to reduce what they charge the end user, but actually just from a maintenance point of view, only have one machine rather than two. That saves them money. Right. So all the time this comes through, and you'll see the wording density. This is what it's about. How do I get more onto those machines? Okay, so how are we getting there? So this is a JVM story. So we need to find a way of climbing this mountain. So now we're going to talk about VM. I've told you about the structure and the table and where we all fit, and and hopefully you can understand this is not just a VM story. Everybody has to play in this. So this is really important. Everybody is already in this mode. What's more interesting is the effect that it's going to have on the people who've already opted in. So if any of you have actually used any of the PaaS services or the infrastructure as a service type things, if you've used Amazon or Google, whether you're doing OpenShift, OpenStack, you take your pick, you've got to use that. And the chances are that the first thing that attracted you to it was that it was free. And you buy and you get something going. And the second thing that attracts you to it is that it scales, the cost scales. And now you suddenly realize that the shape of your application, the thing that bothers you about your application is not how big the footprint is in terms of how big the downloads are or how okay. What you worry about is how much memory is this application using? Because at what point do I jump into the next tier? How much CPU am I using? Right? So they're the decision processes that people are now applying to software decisions. Which ones do I take? Well, it depends. But in some ways, you'd imagine that was always the case. But actually, if you think about it, when you're running this sort of stuff internally on your own machines, if you say, oh, actually, this is running slow, well, it's running slow. You don't buy a new machine. You say, well, it takes longer. All that happens if you run this on the cloud is you just get build more. It's a different story. So we need to think about how we bring these things together. So again, it's a JVM story, but it's also similar to all the other people the same thing. The main thing is there's a real fear of isolation. When you say I'm going to share stuff, people say, well, how will you make sure that this thing doesn't affect this thing? Right? And it's a good question. There's no doubt it is a difficult challenge, right? But hopefully the benefits outweigh some of the risks. So we're saying, well, you've got to be more careful for sure. We've got to be careful about how data is managed, how an application data is managed, and how the isolation works. But actually, from a VM point of view, we've got some ideas and we've got some implementations that show that we can do that. What we have to tell people is those decision processes that you made in terms of organizing what's called your choreography, about when things happen. If you've got a cluster of machines, then you're thinking about when you run things on what machine under what circumstances, and you'll try not to have situations where you have failover plans that fail because you've identified you've got a stack of software and it only runs on this set of machines, and then when one of those machines fails or the software fails, then you're broken. So you'll always be looking for ways of moving, applications around. And when you've got a lot of machines, and especially now you're in the cloud environment, if you're using Amazon or stuff like that, that's one of the things you're thinking about. If you've got large enough of machines, you're thinking about what happens when Amazon goes down. So we're really saying, well, it's not a new problem. You've got to apply the same thought processes to this. So if you've got Java in the mix and you've got a VM that's sharing things, same sorts of thought processes. So I said this is not new. And if you look at some of the biggest users of Amazon, look at Netflix, for instance, they're a great poster child for this. They built amazing failover and work management systems to move things around, and they keep track of what's happening. They see trends happening in Amazon regions. They move things around. So that's what we'll have to do. When you start having Java applications running in these things, then there will be need for people to actually start monitoring an individual VM that's providing these services. Is it starting to go a bit flaky? Do I move my workload around? So isolation and getting people across the idea that isolation is not a challenge and that we know what we can do to provide it, connected with the fact that we need to think slightly differently about how you manage these systems. So that's one challenge. The second challenge is actually getting there. Right? So it's very easy if you're an if you've got a multi-virtual machine environment where you've got hardware and you've got multiple OSs. People use that a lot because it's the easiest. You know how to deal with that. But when you want to move from that to an environment where you're sharing the OS, which gives you more density, okay, so better cost-effective, more density, you start to hit issues. So the issues that you hit most obviously in these things are simple things like file system, port collisions. I have two applications that use the same thing. Well, how do I deal with that? Well, most of those things nowadays can be dealt with. The OS, your ops guys can normally deal with routing work through to different applications. That's, you can front end of those things. That's fairly straightforward. The benefit from doing this is, as I said, you save loads of gigabytes of footprint, and that means real money. Okay, so the reason for doing it's good. The JVM guys, well, we do things like shared classes, so you can turn those on. Because obviously, if you've got the option, if you're running on one OS, then you're going to turn on the sharing options that you can. We already have shared classes, which is a basic sharing of pretty much static data. What we need to do is talk about sharing of non-static data, or rather, more dynamic data. When you try and go to the third level, and you start talking about sharing middleware, well, now you're sharing applications that are running. So middleware in this environment is, yes, it's VMs, but it's also applications running inside the VM. Okay? So we need to start worrying about data isolation. Okay? We think it's always about if your neighbors live a mile away and they have a party occasion, it's not a big problem. If they're next door to you and they have a party every day, then it gets a bit worrisome. Okay, so there are issues with having these neighbors close. And when you're sharing one VM this closely, the other thing we have to talk about is how you deal with what they call resource hogs. Okay, when you look at resourcing and you're sharing resources, you have to understand who manages the resource and who provides it. Who provides the controls? So I said, you know, if you've got a hypervisor, if you're doing the OS sharing, then it's easy. Well, it's easy in that somebody's solved the problem and you've got a hypervisor, and the hypervisor can divvy things up, amount of memory you get, the CPU you get, even portions of CPUs. With a VM, we've got to build that in too. So if we're going to provide a VM that lets you have tenants, then we've got to deal with the resource management issues. So when I start looking at this from a VM point of view, so I'm saying, okay, so I've got a VM and I'm being asked to share as much of it as possible. I want to go multi-tenancy. I want to have user applications running on multiple VMs. So what is it a VM's got that's going to get in the way? Okay, and there's some really obvious things. So heap, well, we can't share objects between heaps. We can't share heap objects between JVMs. So how would we get any benefit? How would we bring these things together? We've got GC. GC, you know, we have a default where GC is one GC thread per core. How do I manage that when I've got multiple tenants, or I've got multiple VMs? So trying to figure out how to bring those things together. We've got the JIT, the JIT's doing all stuff. Can I share the JIT code? It's big, it's complicated. Is it practical to share that stuff? We'd like to, but it's an interesting challenge. And also choreography. I said about the beginning about knowing when things happen. If you've got VMs and they're sharing stuff, so I've got a VM here and a VM here and they're sharing stuff, because we're trying to multi-tenancy share what we can. What happens when VM1 GCs and then VM2 GCs? It's not good. Right? This is complicated. So actually what we really want to do is not have 2 VMs or 3 VMs or 10 VMs that share things. What we really want is one VM that looks like it's a multiple set of VMs. Okay. So that's what we want to try and do. And to a degree, that's what I can demonstrate in my pseudo demo, as you'll see. We've still got ways to go, but a lot of this is just to exploring the space and to understand what we can do and what we can't do. We said we want to do this. What's really important is that this is going to fly you guys. If you are going to turn this on, no application changes. It's got to be seamless. So let's look at what that means. So data isolation, that's the first thing you start to hear. Once you start to get above how do VMs talk to each other and how do you share VM stuff, what about your data? So it's quite often that you'll have deployment information that's stuck in a file. What happens when I've got 2 VMs doing that? Well, actually, what we're really talking about, let's bring the next one up. And this is probably a more example because actually a lot of this stuff ends up being all about statics. What happens when you've got a piece of Java code and you've got a static in it? So here's this thing you can see in the middle. I hope you can see it. It says locale default locale is Canada. So what happens when I've got 2 tenants and they want to have different use of that static? What happens if one wants to set it to US? What happens if one wants to set it to GB? Okay, this is the sort of the nutshell of how do I take an application and make it useful, and how do I solve this problem without requiring you to make any code changes? So we have some usual solutions. So you've probably seen, you may have tried some of these yourself. You can wrap the whole application up in a class loader and it will be completely separate. But you've got to do some code changes yourself. You could go through and fix all the static variables. But again, that would be asking you to change your code. Okay. Well, some people have even suggested that you could go off and do BCI. So when classes get loaded, you can start fiddling with them dynamically and rewriting stuff like this, which is possible, but Probably not as robust or diagnostic as you might want, especially if it doesn't do exactly what you expect. So we need a silver bullet. So luckily we have a silver bullet. Right. Well, here's the concept for a silver bullet. How about we provide you with a VM, a standard VM, and we provide a new option. Very simple one, -XMT for multi-tenant. I'm still quite sure how you spell multi-tenants, with or without the hyphen. It sort of jumps up everywhere. But let's suppose you can do that. You can turn on this simple option, okay, and then wherever you are, Java multi-tenancy, things get shared. Everything runs the same as it does before. It looks to you as if everything is running separately, but under the covers, everything that can be shared, and that includes your application state, is shared as well. So if we do that, then we can make things smaller. So you can get more VMs in, more applications into the same space, which means that at the end of the day, deployment is cheaper, et cetera, et cetera. Okay. Oh, and by the way, actually, some other side effects. JITting and GC benefits everybody, and so there's some less CPU overheads on some of these things. But also, in many ways, you've already got a warm start, because you're coming in to join. If you've got VMs that you're starting, then they're starting in an environment where there's probably a VM already running. So in many ways, your startup can be a lot quicker. So depending on what's going on, but our general view is that you will gain a benefit just by having another VM running. And of course, as I said, no code changes, please. So I'm going to give you a demo, but it's not really a demo because it's just screenshots. There are two reasons for that. Mostly because it was difficult for me to get the demo set out for you, but also it's not a very exciting demo, so I don't think you lose very much. So I said about adding this -XMT option, and you can see it there. I hope you can see it there. So that's what you do. Let's just run one of these things, Java -XMT, specify a jar file, whatever it is. Okay. So what happens? Well, in this experimental technology, when you do that, there's a process that we'll go through, and we will start what we're calling a daemon. And it will run in the background. And though it looks like it's running in your local process, it's actually running in this daemon. So this daemon has got a tenant. So the first person in takes the cost of starting up a VM. It sits in the background. Okay? And that means that when a second one comes in, and if you notice, the name of the jar is different. So this isn't a shared classes thing where we're saying, well, you've got restrictions on what you can and can't share, and if you move outside that, you get a different VM. And this is whatever you want. You say it, we'll figure out what we can share. So when you do that, right, you get a second one, and you get a second tenant. Startup is pretty fast, and we've shared an enormous amount of the runtime, right? Because we know what we can share. So the Java runtime itself is shared a lot, and a lot of your application. If you're running the same application twice, then pretty much all of it that can be shared will be shared. Right? We can figure out how to do that. So the question is, well, what do we do? Well, strangely, almost all of it comes down to fixing up these static variables. And if you think about it from a Java point of view, you have a Java graph, then to a degree, you can keep a Java object separate from another set of Java objects. It's not a big deal. Now, this is not the only thing that we're fixing, but this is the one that everybody gets excited about because this is the sort of the macrocosm of the solution. There are other things going underneath the system, so you have to deal with, for instance, full file paths and things like that. You have options on those. You've got options to redirect those and say every file path that I pass in, if it's an absolute path, well, actually, it's going to get manipulated slightly to make it less absolute or have a different location. Those things we can deal with. This thing is about dealing with local statics. So what actually happens here is we add a new annotation. Right. So from a Java point of view, what we're now saying to the VM is that you can have when you load up this class, make space available to have multiple versions, multiple variants of the default locale field. And the variant that you should use is based on the tenant that you're running. So it's tied to the tenant. Okay? And so from each tenant's point of view, they'll get the value they want. They can set the value. That's great. If they don't touch the value, they get whatever the default value is. And if somebody else changes it, then you don't get to see. It doesn't affect you. So you get complete separation, complete isolation. And I said, no code changes. So why would I add in, if this tenant scope idea was invisible, so you don't need to worry about it, why would I actually talk about it? Well, actually, the reason that we need to be able to make this available to you is because there are people who want to opt out being kept in the dark of what's going on. Middleware, right, if we want middleware to participate in sharing as much as they can, we don't want to fake out the Java piece of that middleware that's running in your application, in your VM. We don't want it to have separate things. We want to provide it the opportunity to say, actually, I can manage my shared data for that tenant, thank you very much, because I know what I'm doing. So that's why we have this idea of being able to say you can, because those annotations, we inject them, but you can go mark them yourself and say, please don't share me. So you can build applications that are intrinsically not shared in a multi-tenant world. So, as I said, it's there to let you opt out if you need to, and there will, if you're doing middleware, JDBC drivers, whatever, you may be going, in this world I need to know I can do a better job of dealing, because I can understand what my data is shared and not shared compared to what the tenant wants, better than the VM can figure it out. It also gives you some connection between the tenant, so you can actually go back and say, I can look at it and say, hey, this particular tenant that's causing problems. So as well as providing a tenant scope annotation to enable this stuff, underneath covers, we're also providing some APIs that you can, you can interrogate, you can ask questions about tenants, you can go look at what resource usage they've got. So these sort of under the covers APIs. So is that it? Well, there is one other thing to deal with, and this is the sort of non-functional part of squidging all this stuff together. So we've got data isolation, we can deal with that. The difficulty that many people will point out is, well, who've you got managing the resources? So file systems, CPU usage, all those things. So let's just pick one like CPU usage. That's fairly interesting. How would you go about trying to manage how much of the CPU you would give to one of these tenants? So this isn't a tenant story. It's you as a deployer of a tenant who says, actually, I want this tenant to have 30% and this person to have 60%. Okay. So we've looked at what needs to be done, and we can provide some controls on most of those things. So CPU we can deal with. Heap size, well, that's actually fairly straightforward if you think about it. Just deal with things like thread count. File I/O, we can allow you to restrict how often you can read and write. So you get percentages compared to other people, so you can manage those. And same with sockets. But actually, the thing that I find interesting in the CPU time, that's the most interesting one for me about how you go about making this happen. So we've got options. So you can literally go along and say, I want this tenant to start. It's going to run this jar. It's going to have, we're going to say the range of CPU it's going to use is between 10 and 20% or whatever. Okay. And you can say like bandwidth. So you can restrict, throttle, bring it all down. Okay. And we do that within Java. And other bits and pieces to go with that. Now we're not building this all completely on our own, as you'd imagine. There's a great JSR out there, 284, which has been around for some time, and this is all about resource consumption management. So it's got the ideas of how you describe what you want to do, and what we've done is basically taken that and built it into the VM. So that means that effectively, if you can get the OS to provide the resource management for you, so Linux is a great OS for providing some of this. So if you can say the OS will do the workload management, ask the OS to do it, and if not, well then the VM will do it. Right. And I'm glibbing all over this, but actually, it's actually quite doable. So here's the CPU throttling. I'm not sure if you can read the numbers, but what we did was we took a benchmark and we said CPU intensive benchmark, 10 threads or thereabouts, let's just run it, okay? And the interesting thing is, on the left is the OS throttling. So what we've actually got, I'm not sure if it comes across too much in this, is there's a pink and a blue line. The pink line, which is the bottom line, is one tenant restricting to, I think it's 30%, and the blue line is a tenant restricted to 60%. So you get about 100%. So we're saying you get 1/3, you get 2/3 of the CPU resource. So the Fibonacci benchmark, which is doing loads of CPU stuff, so you know, 100, it's going to drive the CPU as hard as it can. So the resource control that we've built into the VM, as I said, will rely on the OS capabilities if it's there, and if not, it'll do itself. You can see that we get pretty much the same sort of separation. On the left, you've got the OS doing the work, and on the right, you've got the JVM doing the work. So, okay, the VM is not as accurate, but actually you can see that there's not that far. You get a broad effect. Right? You are actually able to control that, and we're getting better at it. Okay, so let's just talk about what that means. So let me try and bring all this together. So let's talk about, how do you demonstrate the benefit of something like this? So one assumption is that it's not going to break your data, we're not going to break your application. So yeah, we think we can do that. That's a testing. But you want more than that. You want to say, what extra value do I get? Do I get the density that I would expect to get that I'm saying you could possibly get? So if you take, you run some standard benchmarks. So we've got here a 1-core, 1 GB VirtualBox setup, okay? And we basically run Java applications. Okay, so we have this benchmark of the application. How many of those can we run until it swaps? Okay, the more you can get, the better we're doing. So you get that? So you get a 1 GB virtual machine, a Linux virtual machine, VirtualBox machine. You start Java applications that are doing the same workload, okay, and you keep doing that until you see the swap take place, at which point you've filled up the space. So the question is, how much can I get a tenant down to compared to what I had before? So with a standard JVM, and what that means is we did no tuning. So I just run this. How many do I get? I think it was about 18. So it doesn't really matter what it's doing. Okay, it's all doing the same thing. The question is how good are we at reducing the overhead, reducing the amount of data that we're not sharing, consolidating. So I can get 18 instances thereabouts out of the box. Well, if I ask somebody who knows what he's doing to come along and hand tune that VM, the best we could possibly do by hand, I get something I think it's about 50. So that's not bad, right? And that's good because we can make money out of sending out these guys, consultants, to go out and tune your VM to get you double performance. Okay, that's great. So anyone going to hazard a guess what multi-tenancy? Is it going to be taller bigger than 45, 50? Yeah. I wouldn't be standing up here if it wasn't, would I? Yeah. So it's close to 230. So we can get, given it's a gigabyte, we get about, maybe it's even 250, but we were getting 4 meg per tenant, right? That's the non-shared piece of the data of this app. And if you go and dig the application, then that's not bad. The rest is we're saying, well, look, this is common to all the other instances and we can share them. Okay. So you take something like that, capability and you add in the CPU throttling that we can do with this, and you look at some of the other resource controls that we're building on top of sockets and bandwidth and stuff like that, you can see we actually have a real opportunity here to actually make this useful. So to wrap up, well, what can I say? It's still experimental. We've done some pretty good stuff. We would really like you to give it a go. It's sitting, you can go Google for IBM Java 8 beta program and go download it, and you can go play with it yourself. And it's all documented, there's examples, go off and try it, and it'll break. I'm sure you'll find things are wrong with it, but it is a beta, it is an experimental. But even so, we'd be very interested in your feedback, not only about the fact that it breaks or it doesn't break, but actually whether this is something that you would be willing to see go further. We would love to standardize this. We've already got one JSR, which is the 284 JSR. There are other ones knocking around. We're going, is this good enough? Is this what people want to see? If we produced it, would people want to use this? That diagram I showed at the beginning of all the stacks, one of the things I find interesting is exactly where in that mix are we really going to stop? What is it that's going to be standard behavior for everybody, standard configuration? We're exploring all of them. This is almost the top of the stack. There are other ones we can go a little bit further, get the database guys to do a bit more. But the question is it something that you would use? So I think pretty much that's it. Hopefully I've answered some of those questions. I won't bother to read them out. We really want to know whether you like this. And I said, just email me or just turn up on the IBM beta, and there's a forum there. You can talk about it. If you like it a lot, you can go talk to the London Java user group and say, well, I saw this great thing, this talk by Steve Poole on multi-tenancy JVMs. This is great. Can we do something with it? But even if you don't like it, I'd like to know, because any feedback, good or bad, is very valuable to us. So, well, thank you very much. As I said, if there's any feedback, please let me know. That would be great. Otherwise, thank you very much.